peroxide radicals. Radicals means where there is one electron unpaired. So when you draw the oxygen atom, you have atomic number 8, configuration 2, 6. Am I right, Aaron? So
Yeah.
RO, we have 1, 2, 3, 4, 5, 6, 7. Oxygen is supposed to have electrons in its boundary. Are we understanding? We learned the bonds, right? Oxygen is supposed to have electrons in its boundary. It has 1, 2, 3, 4, 5, 6, 7. Are we understanding?
Yeah.
So it needs one more, right? How does it do? Going forward, step two, what is it going to do? So we will have the RO molecule and we will have the CH2, double bond CH2. So this bond is actually going to break. So we're going to have this and we're going to have this. RO, so now you are still heating, step two, you are still heating what? You are still heating the bond. So this comes here and this also comes here. So what do you have? So one electron shall be here, one shall be here. Because once you heat both sides, again we have carbon. So you're going to bond and you're going to bond. Why is that? So this is going to attract here. Got the point? So now RO radical brings its own electron, the red electron, and it forms a bond here because the carbon has one of its electron here. And carbon has one of its electron here. Are we understanding? So this is
Mm.
first stage. Now what exactly happens? Another molecule of ethene comes. And we have all the molecules together. Are we understanding this part? So then what is happening? You heat it again. So this bond again breaks. This bond again breaks. When this bond again breaks, so what do we have? RO. And we have
Mm-hmm.
CH2 single bond CH2. And then what do we have? We have CH2 single bond CH2. We have one electron here and we have one electron here. So this electron is a bond together again because this CH2 and this CH2 will make a bond. So we'll have a longer chain. Got the point? Again, so easy. Similar molecule. And we have not stopped heating. So because this is a one bond, so one bond of them is weaker. So once you heat it, this bond opens up like this. Right?
Mm-hmm.
We'll have these two electrons here, and that's going to make a bond here.
Yeah.
This is going to connect. Are we understanding? And then we'll have another molecule of CH2, CH2. We'll have this and we'll also
Yeah.
have this. So this bond again breaks down. So I hope you're understanding what do we have. So we'll have RO, we'll have
Mm-hmm.
CH2, 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 CH2. So this is my second molecule. And what change are you noticing here? We have double bond, right? And this double bond, it kinds of breaks into a single bond. For every molecule, the double bond breaks and we get a single bond, right? Are we understanding? Any doubts in this system?
Mm.
Right? Then again, we have the molecules, so we'll have seen, and this process will continue. So you understand that a single monomer is forced to connect to other monomers to form a long chain polymer. Are we understanding?
Mm-hmm.
Any doubts in this? Got the point or not? Got it?
Yeah.
So that's the idea. So we have this. Understood or not?
Yes.
Got it? Yes or no? So this chain continues and continues and continues and it keeps continuing. Got it? Got the point or not?
Yeah.
So that's the point. So that's how they connect. So now you understand that we started with ethene and we have come up to a point where I've created polythene. So do you realize where polythene is? You must have seen the packing of lot of equipments, right? So equipments and small equipments. So what do you get to see? Generally, most of them are either packed in thermocols fixing, or most of them are kind of packed in a small plastic bag. Or let's say if you get something to eat from a grocery shop, you must have eaten biscuits, you must have eaten chocolates. They must be having some wrap onto them. So they have a polythene wrap onto them, right? So a plastic wrap. Sometimes the books are also wrapped up with the plastic, right? We go to a shop and if we are very keen, we take care of what? We take care of the environment. So then we would use the paper bags. But in case we're not so, environmental conscious, then probably we might use the plastic bags if you have seen those. So that is where the polythene is being used. So every
Hello.
plastic or poly bag is basically a polythene. Are we understanding my point or not? Yes or no? Is this part clear?
Yeah. Yes.
Got the point or not? Got it? So that's the idea, right? Now, so how do they join? So we say we write down the name of the polymer here, and because we have the name of the polymer, we will also have the monomer, right? Or I should do it vice versa. We will have the monomer and we will also have the polymer. Are we understanding? The
Yeah.
first part we have is the first part that we have is the monomer, right? So the monomer is ethene. So when ethene join multiple times, we get polythene. Second part is propene. So we'll have polypropylene. So all you have to do is just replace or prefix every polymer's name with poly because poly means many and that becomes the name of the polymer. Are we understanding?
Yeah.
Then we have polyacrylonitrile. So we'll have acrylonitrile. So we will have polyvinyl chloride. And here we're going to have vinyl chloride. Are we understanding? So we are going to have vinyl chloride and here we're going to have polyvinyl chloride. Yes or no? So we have a
Yeah.
ethene to polythene, propene to polypropene, acrylonitrile to polyacrylonitrile, vinyl chloride to polyvinyl chloride. Yes or no? So we will have isoprene. What is isoprene? It is buta 1,3 diene. All right. So isoprene is basically buta 1,3 diene is the monomer, and we get isoprene. What is isoprene? It's a natural rubber. Got the point?
Yeah.
Next, what do we have? So here we're going to have neoprene. So neoprene is my artificial rubber. Then we have the monomer I'm going to write down. We're going to have buna S. What is it? Buta 1,3 diene plus styrene. All right. Then what do we have? We have styrene, and from styrene we get polystyrene. All right. Then we have nylon 6,6 polymer. That's a polymer. Then we'll have nylon 610. Are we understanding? So we'll have nylon 6,6, we'll have nylon 610. Got the point?
Yeah. But why are the numbers there?
Right. So what are these numbers? So these numbers basically, see, understand. Nylon 6,6, nylon 610. What are these basically? These are basically the heteropolymers. Now there are two types of polymers. One is heteropolymer and one is a homopolymer. Now, what do you mean by homopolymer and heteropolymer? Just understand. When we have the homopolymer or when we have the heteropolymer, what does that mean? Heteropolymer has two or more different types of polymers, two or more different types of monomers, two or more different types of monomers. Homopolymers, there are same type of monomers over and again. You have same type of monomers repeating over and again. Are we understanding?
Yeah.
Yes or no? So when we have heteropolymer and we have homopolymer, what does that mean? Just tell me. The homopolymers we have, the homopolymers, they are made up of just less like ethene. Ethene is repeating itself multiple times. Ethene, 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 and we get polythene. Are we understanding? So we have ethene, 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 and we'll have polythene. Are we understanding?
Yes.
Got the point? And similarly, styrene, 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 and then we get polystyrene. But if I talk about nylon 6,6, it basically means what? It is basically hexamethylene diamine, and it also has caproic acid. So it is basically kind of, caproic acid has six carbons in it, and hexamethylene diamine also has six carbons in it. So basically, these numbers they represent that if you have two monomers, both of them will have 6 carbons in them. Understood or no? Any doubts? Yes or no? Got the point or no? Now, if I'm talking about 610, so again, one would be hexamethylene diamine, and second would be what? Decanoic acid. All right. So one will be hexamethylene diamine and one will be decanoic acid. Do you understand my point? Right. Then what do we have? We're going to have, so let's say we have pterylene. So we'll have pterylene, right? So what does pterylene means? What does pterylene means? It's a polyester, right? Pterylene also has a different name called as dacron. Pterylene also has a very different name which is called as dacron. Got the point. Understood? Yes or no? Right. So it is a basically kind of polyester. It is basically a kind of polyester. Got the point? Got it? So how does it work now? Just see. So let's say if I tell you what is hexanoic acid. Hexanoic acid has a very different name, which is also called as caproic acid. Got it? So you'll have one, two, three, four, five, six. Got it? So caproic acid, hexanoic acid is this. 1,6-dioic acid. So this is my hexane 1,6-dioic acid. And hexamethylene diamine, NH2, it will have 6 CH2 units and then we'll have NH2. That's the structure. What I'm trying to tell you is, see, understand, when these two join, so what do we get?
What is the...
We have this structure, right? So we have this structure. Got the point? So you remove water from this.
Yeah.
You remove water from it like this. What is water? OH negative and H plus. When they combine, they form water. Are we understanding?
Yes.
So when we have water, what does that do? Right? So what kind of structure do you think I'm going to have? We're going to have CH2 whole 4, C double bond O. We'll have NH. CH2 whole 6, then again we'll have NH. Then again we'll have NH. Yes or no? Something like that. And like that. So you see this CONH unit is repeated over and over again. This unit is called as amide unit. So once we have the amide unit, what exactly happens in the amide unit? Just tell me. Once we have the amide unit, what happens in this amide unit? Just tell me. What exactly happens in this amide unit? So we will have this hexanoic acid. Got it or not?
Yeah.
Right? What does that mean? We have this amide unit, or nylon thread. So this is the polymer, right? And nylon thread is kind of what kind of polymer? It is made up of two different types of monomers. Yes or no? So because it is made up of two different types of monomers, what does that mean? Because it is made up of two different types of monomers, what does that mean? Just tell me. Because it is made up of two different types of monomers, what does that mean? It is a heteropolymer. So nylon 6,6 is basically a kind of heteropolymer. Are we understanding the point? Yes or no? So nylon
Yes.
6,6 is a kind of heteropolymer. Understood my point? Got it? And also, it is a kind of polyamide. Why it is a polyamide? Why is it a polyamide?
Polymide.
Why is it a polyamide? Just tell me.
Mm.
Because the amide linkage is getting repeated again and again. And what is amide linkage? Amide linkage is basically formed from those substances whose one part is COH and one molecule has NH2 group. So any molecule with NH2 group and any molecule that is called as a carboxyl. So just you know,
Oh, I see. Yeah.
are you, that's it. Are we understanding? And if that molecule has NH2 group, then it is a amide. Any doubts in this? Any doubts in this? Just tell me. Got it? So that's the basic idea. So when we are dealing with the NH2 group, when we are dealing with the NH2 group, what does that mean? This is amine, this is amine, this is amine. Are we understanding?
Yeah.
Got it? Got the point. So we have the hexanoic acid.
Yeah.
That's my hexanoic acid. Got the point? So we have this carboxylic acid. And this is got it? So that's about nylon 6,6. Now, if there are certain molecules, and you'll have CH2 whole 6, COOH. So you remove water. So one molecule which has just OH into it is called as an alcohol. And one molecule which has COH group is in it is called as carboxylic acid. So when carboxylic acid combines with alcohol, when carboxylic acid combines with alcohol,
Yeah. To form esters.
esters. So you look at this part, what do we have? We'll have this link sharing again and again. This linkage, this linkage. Yes or no? So when we have this is my ester linkage. This is my ester linkage. Got it? So when we have this ester link, yes or no? Got it? So I hope you're understanding that we have this ester linkage. Got the point? So this ester linkage will be what? This ester linkage is basically repeating again and again in the long chain, and that's what makes it as a polyester. What's the point or not?
Yes.
Got it? So that's ethylene glycol. Got it? So that's the idea. Got it? Any doubts on this? Are we understanding?
Yeah.
Right. So thereby, how do we classify the esters now? So we classify the esters in the form classify the esters. So we classify the esters as homopolymers. So what kind of polymers come in the category of homopolymers?
There's polyethylene, polypropylene. Yeah. Um,
Yes or no? That's what we have. So we will have the homopolymers and we will also have the heteropolymers. Homopolymers generally, so let's say if I say polystyrene.
uh-huh.
So polystyrene lies in the case of thermocol. Right? Polystyrene lies in the case of thermocol. Got the point? The polystyrene is also called as thermocol. Is it clear?
Right.
you have, you know, rubber, which is used to make the inverter batteries. So it's a very hard battery, hard plastic. So it is made up of styrene. Styrene is this structure. Benzene and CH double bond CH2. And we will have butadiene, butavanadiene. Are we understanding? No. Got the point or not?
Yeah.
That's the basic idea we have. This is going to be butavanadiene, and this is going to be styrene. Got the point?
Yep. Yep.
So when they join together, so we have polybutadiene or the natural rubber being formed. Understood? Yes or no?
Yes. Understood.
So that's the basic idea we have. Got the point or no?
Yes.
Got it? So that's the idea. Right? So do you understand a little bit of polymers today? So what
Yeah.
we have to learn here is the type of polymers, and we have to also learn about, how does the polymerization mechanism works? How many different types of polymers do we have, and what is the monomer of each polymer? So that's what we have to learn today. Understood or not?
Yes.
Right? That's it. All right. Thank you.
All right.
Okay. Done.